Hi there, welcome back to this great economy lecture on financial maths. So today we're going to be having a look at how we can use the sum of a geometric series formula to solve different financial maths questions. Okay, so I'm not going to lie to you, these are really difficult. However, the only way to get good at them is to constantly do exam papers, book questions, and just constantly be practicing the process. So we're going to try the 2014 sample paper 1, question 8, part C. So Podrick is 25 years old and is planning for his pension. He intends to retire in 40 years' time when he's 65. So all of this is very important. 40 years' time, 65. First, he calculates how much he wants to have in his pension fund when he retires. Then he calculates how much he needs to invest in order to achieve this. He assumes that in the long run, money can be invested at an inflation-adjusted annual rate of 3%. Your answers to this question should therefore be based on a 3% annual growth. Part C, Podrick wants to have a fund that could from the date of his retirement, give him a payment of €20,000 at the start of each year for 25 years. Show how to use the sum of a geometric series to calculate the value on the date of retirement of the funds required. Okay, so I'm just going to again highlight some key information. So it mightn't seem important, but we're always going to highlight the start of the year. Okay? Okay. And I'm going to explain why now in a second. So, a bit of a top tip for you. What I always recommend is that we are going to assume that it is the start of the year. So let's presume it is January 1st, 2021. Okay? And we are going to do a timeline, and we are going to assume the present moment is the earliest point on that timeline. So, for example, what is the earliest point in time on this timeline? Well, the earliest point in time is when he retires. Okay, so we're going to call that P. And what's going to happen is every year he's going to take out €20,000 out of this pension fund, and that is going to last for 25 years. Okay, so because it is the 1st of January 2021, and he takes out €20,000 at the start of each year, well, is there going to be any interest on this €20,000 when we bring it back to the present moment? So, like, for example, that €20,000, is that sitting in there for any amount of time from the day he retires? And the answer is no, because he is also taking out that €20,000 on the date of his retirement. And if that doesn't make sense, don't worry, it'll start to make sense as we do more now in a second. So we're just going to leave that €20,000 as it is. So the next one, how long is this €20,000 sitting in here for? Well, it's going to be 1 year after he retires. So this €20,000 was at the start of each year, so that's why it was on the date of his retirement, and he just took that out straight away. This one is a year later, so it's the start of 2022. So this one is going to have an interest. Yeah, it's going to have built up an interest of 1 year. So when we are bringing this back to the present moment, we need to take this into account. So there is a formula in our log tables that says P equals F all over 1 plus I squared T. So this €20,000 is the future value. Okay, so he's taken that €20,000 out in the future. So we need to just put in I and T. Okay, so we're going to divide by 1 plus I. So I is 0.03, and T. So this has been sitting there for 1 year, and that's been sitting there for 1 year, so T is going to be 1. And then we're going to have plus. We're going to have 20,000 all over 1 plus 0.03 power 2. And this is going to go all the way up until 20,000. So if this is going on for 25 years, what is this value of T going to be here? And some of you might say 25, but if you think about it, if we say 25, then we're going to have 26 payments, and he's only taking out 25 payments. So this has to be 24, okay? Because if you think about it, on that 25th year, he's not getting any interest for that final year because he's taking it out at the start of that year. So that is why this is 24. So again, just a little top tip is that we are always going to assume that it is either like t is either 0 and 1 minus whatever we have. So let's say 24, or it's going to be 1 and 25. Okay, so yeah, just again, that might make more sense now, but as we do more questions, that will hopefully make more sense. So, by the way, I forgot to put our plus dot dot dot, plus dot 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 plus. Okay, so that's going all the way up until 24. Okay, so now we need to use a sum of a geometric series formula to calculate this. So I've just written down the sum of a geometric series formula, and we're going to have a go at filling this in. So if we have a look, so what is our A? So our A is our first term. So our A is going to be 20,000 euro. So Sn is going to equal to 20,000. 1 minus, or what's or? So what are we multiplying by each time? Well, we have 20,000. And then the next term is 20,000 divided by 1 plus 0.03, is it? Yeah. So what are we multiplying by each time? Well, it looks like we're multiplying by 1 over 1.03. So that is what we're multiplying by each time. As you can see, this power is getting bigger on the bottom, so that just confirms that is our common ratio. So we are multiplying by that each time. So our OR is going to be 1 all over 1.03. And our N, so how many terms do we have? Well, we have 25 terms, okay? I know this goes up to 24, but when we're using the sum of a geometric series formula, it's how many terms do we have? Well, we have 25 terms. So, and that's going to be all over 1 minus our OR, so that's 1 all over 1.03. And if I type all that into my calculator, I will get 358,711 to the nearest euro. Okay, so that is that question done.